Greetings. This is just a walkthrough of this practice test. You've already got the answers on with the key. So here's where those answers came from. Let me walk through each one of these problems. Now, number one, simplify each expression by using the indicated operation. And I've got this polynomial minus this. Remember, if I'm subtracting a polynomial, what that means is that subtraction is going to apply to every one of those terms. So I'm just going to rewrite this first set of parentheses, 4 minus 5a squared plus 3a to the fourth. By the way, do not assume that these powers are in order, either forwards or backwards, because that's not always the case. Minus a negative, that's plus 10, a to the fourth, minus 1, so I'm going to change all of these signs. Minus a positive gives me a negative 8a cubed. Okay, now these terms are alike. I'm going to look for the highest power first just to get it in order when I put it back there. I see a to the fourth and 10a to the fourth. So these are both a to the fourths. 3 plus 10 makes 13 a to the fourth. A cubed, that's the only one right there, negative 8a cubed, so negative 8a cubed. Minus 5a squared, that's the only a squared I see, right? Yeah, that's the only one. Minus 5a squared, and then 4 minus 1 is a positive 3. Bingo. Okay, that's a little small. Let me focus in on that just a bit. Okay, I think that'll be better. Perfect. Okay. 2x minus 7 squared. Now, the number one mistake I see is people will square this. You've got to realize if I see a binomial like that squared, that means take it and multiply it by itself. If you can hear that background noise, that's they're waxing the floors in the hall. It's what they do at 10 o'clock at night. 2x times 2x is 4x squared. So I'm just distributing here. 2x times negative 7 is negative 14x. Negative 7x, negative 7 times 2x is another negative 14x. And negative 7 times negative 7 is a positive 49. So, sorry, they'll pass by in a bit. I get 4x squared. Negative 14 minus 14, those are like terms, gives me negative 28x plus 49. There. Cool. Now, this times this. It's another distribution, and I'm going to go 3x squared times 2x. That gives me 6x squared. No. 6x cubed, because I've got 2 and 1. So I'm going to add that 1 there. Remember, I add these. 2 plus 1 is 3. 3x squared times 8. 8 times 3 is 24. It says x squared. That doesn't have any, so it's just x squared. Okay. 5x times 2x. These both have 1s there. 5 times 2 is 10. And x times x is x squared. Now, I started to stack those so that I can just combine the like terms by adding them straight down now. 5x times 8. 5 times 8 is 40. And I've got x. Negative 4 times 2x. That's negative 8x. And then negative 4 times positive 8. Negative times positive makes negative 32. I collect my like terms. I've got 6x cubed. It's the only one. 24 plus 10 make 34. X squared. 40 minus 8 make positive 32x minus 32. Beautiful. Okay. Determine if x equals 1 is the solution for this. Now, if I had this graphically, I could graph y equals this and y equals this, and I'd see if they cross at x equals 1. You will not have access to a calculator when you do that kind of problem, okay? I mean, a graphing calculator like Desmos. You will, however, if you use other kind of things, but we'll talk about that later. The easiest way to do that is just put the 1 in there. So I've got to go 4 times 1 plus 2 cubed equals 32. So I just put 1 in for x. I need to see if that's true. The way I would do it is I would pull out my calculator, and I would go 4 times 1 plus 2 parentheses cubed. That looks like that, right? If I hit equals, I should get 32, right? If it's true. Equals, and I get 108. So you know what? It ain't true. So I would say, nope, not true. Because I plugged in and I checked. Okay. Now solve each equation algebraically and then check your answer graphically. If you're being told to do something graphically, you will have access to check it on Desmos. I'm going to tell you right now, you will have to solve this kind of equation algebraically, and you will not have access to Desmos to check it. Okay? I just want you to get in the habit of graphing some things, doing that. You can check it. You can check your answer that way. Okay. We had three kinds of equations we dealt with. Linear ones where there's no absolute values or powers. Absolute values where we have the absolute value. And then quadratics where I have that power of 2. So to do this, I got to simplify that and simplify that. That's already done, but this is not. I to distribute here. 3x plus 4 times 5 is 20. 4 times negative x is negative 4x. Equals 12x plus 4. Okay, 3x minus 4x, that's negative x, plus 20 equals 12x plus 4. Okay, now these are simplified. Now I can combine the like terms. I'm going to add x to each side, and I'm going to subtract 4 right now. That gets rid of the minus 4 here and puts it over here. 20 minus 4 is 16, equals 12 plus 1 is 11x. And if I divide by 11 on each side, I get x equals 16 elevenths. And I could check that by substituting it back in. I don't like that. I'm going to check it. 3 times 16 elevenths plus 4 times 5 minus 16 elevenths. Okay, I get 204 elevenths when I do that. Now I need to go 12. I'm going to do it with the right side. Times 16 elevenths plus 4. I get 236 elevenths. I've done something wrong. Crud. I feel dumb. Let me look. 3x plus 4 times 5 minus x. Okay. 4 times 5 is 20. 4 times negative x is negative 4x. 3 minus 4x is negative x plus 20. Okay. Equals 12x plus 4. And if I add x here and add x, there it is. What's 12 plus 1x? It's not 11. It's 13. And so this isn't 16 elevenths. It's 16 thirteenths. I still don't like that. It looks ugly. But I can go check it. Okay. I get 244 thirteenths if I plug it into the left side. And if I plug it into the right side, and the way I did that in my calculator is I just kind of went up to get to the previous operations. I get 244 thirteenths. Okay, so 244 thirteenths, and I've forgotten already, is that what I got on the other one? 12 times 16 thirteenths plus 4. 244 thirteenths. Okay, so that's it. That is, even though it looks ugly, it's okay. I don't need you to change it to a decimal. Now, let's look at this. 17 minus 5x minus 1 equals 41. To solve this, I have to isolate this absolute value, which means I need to get rid of that minus 1. And I have 7 minus 5x equals absolute value of 7 minus 5x equals 42. Once you got it isolated, now you do two different equations. 7 minus 5x equals 42, and 7 minus 5x equals a negative 42. Remember, you said it, the positive and negative one. Now I'm going to subtract 7 from each of these. and I get negative 5x equals 42 minus 7 is 35. And if I divide by negative 5 on each side to cancel out that negative 5, I'm having to squish this in. X equals negative 7. Okay, here, if I subtract 7, I get negative 5x equals negative 49. And if I divide by negative 5 on each side, I get x equals 49 fifths. So these are my two answers. X equals negative 7, x equals 49 fifths. I'll be honest, on the practice test, I did kind of squish things together so I could put it on one one page. The real test, you'll have much more room. Okay. Whew, let's look at this one. This is a quadratic. So on quadratics, you need to set it equal. Quadratics. You either need to set it equal to 0 and then factor and solve, or this one's kind of nice. I can divide by 4 here. I can isolate that squared, and I get x plus 5 squared equals 1/4. One of the big things you need to remember is when you take the square root, like I just did there to cancel out that squared, I get x plus 5 equals a positive or negative square root of 1/4. And if I put square root of 1/4 in my calculator, I get 1/2. Then I subtract 5 from each side, and I get x equals negative 1/2 minus 5 is negative 5.5. Positive 1/2 minus 5 is negative 4.5. And there's my two answers. Okay, now let's move over here. Solve the following equations by graphing. Sketch the graphs in the coordinate plane below. This is one where if you're told explicitly, solve it by graphing, you're going to have a graph in decimals. Now, if you were to graph this, that is 3x minus 2 equals y. You graph y equals the left side and y equals the right side. Let me think here for a second. And that one's going to look like that. And they're going to cross right there. Now, I don't have decimals up, but let me pull it up real quick and graph those. I'm just graphing them by hand for a moment. I hope I'm right. Pretty sure I am. 3x minus 2y equals, and I know you can't see this. I'm just graphing them in my decimals. You could pull out decimals right now and do the same thing and type it. I'm going x minus 2, absolute value of x minus 2 plus 1. And sure enough, my graph looks exactly like what I just drew. And it crosses at the point 1.25. Oh, I lost it. 1.75. Okay, that's not the answer. Your answer is x equals this 1.25 because it's where x equals that. It's the x value of that. Okay, now I've got this. Y equals 0. That's going to be this line right here. So I got to graph y equals 0 and y equals this thing. Wow, that's going to be more complicated. So let's do that. Y equals x to the power of 4 plus x to the power of 3 minus x squared minus x. Whoa, that's kind of cool. I like that. That one looks like this. It looks like and goes through there and goes up through there. Awesome. And this actually has 3 points where it hits right here at negative 1, 0, right there at 0, 0, and right there at the point 1, 0. So this has actually 3 solutions. X equals negative 1, 0, and 1. Because it has 3 points where it crosses. That's what you're doing. You're graphing y equals the left, y equals the right, and seeing where those things intersect and reporting the x intervals because that's where they're equal is the x values. Okay. Moving on. Solve each of these algebraically. Check for extraneous. You got to make sure you do that. Okay, so remember, I isolate, bring to a power, solve what's left, and check. So I'm going to subtract 5 to isolate this first. That gives me the 4th root of x minus 10 equals 3. 8 minus 5 is 3. And then I bring to the power of 4 because that's the index. Well, 3 to the power of 4 is 81, right? Yes. Minus 10. I can't believe I forgot the whole minus 10 thing. That's the kind of mistakes that I make. I just make dumb mistakes, forget things totally. So x minus 10 equals 3 to the 4th. 3 to the 4th is 81. Add 10, and I get x equals 91. And if I put that back in here, 91 minus 10 is 81. 4 through 81 is 3. 3 5 is 8. Check, that works. Okay. You don't have to actually write out how you check the answer or whatever. You can just plug it in, work it through your head. That's just fine. Okay. Now, this one. I've got to isolate, bring to a power, and solve what's left. So to isolate this, I need to get rid of this minus 5. So I'm going to add 5 to each side. That's going to give me 13 plus 5 is 18. And then I'm going to divide by this 2. Okay, let me rewrite so I don't get myself confused. I've got now x plus 5 to the power of 2/3 equals, I did 13 plus the 5, that was 18. And then I divided by that 2. 18 divided by 2 is 9. Right? Right. Ooh, I don't like what's going to happen here. Well, maybe. Okay, now I need to bring to a power. The power that will cancel this 2/3 is 3 over 2. Remember, if it's a rational exponent like this, you flip this fraction, 3 over 2, 2 over 3, change it to 3 over 4, bring each side to the power of that flipped fraction. That's going to cancel, and I get x plus 5 equals 9 to the power of 3/2. Make sure you know how to enter that in your calculator. My calculator, I do it exactly how it looks like, and I get 27. And then I just subtract 5, and I get x equals 32. And just to save time, I can type that in there, and it'll give me my right answer. Check. Now, this one, x minus 5 equals 49 minus 8x. Whew, these are a little tricksy. This is already isolated, so I need to square both sides. That's going to cancel, and that'll give me 49 minus 8x. But over here, x minus 5 squared is x squared minus 10x plus 25. And if you're wondering where that came from, x minus 5 squared means x minus 5 times x minus 5, right? And if I distribute that through, negative 5 times x times negative 5, there's the negative 10x. X times x, there's the x squared. Negative 5 times 5, there's the 25. Okay? Now, this is a quadratic, so I've got to set it equal to 0. Okay? You will be expected to be able to factor something simply. So I set this equal to 0 by combining my like terms. I'm going to add 8x to get rid of that. I'm going to subtract 49 to get rid of that. And I get x squared minus 2x. 25 minus 49 is negative 24 equals 0. Okay, this will factor. X minus 6, x plus 2 equals 0. And I set each of these equal to 0. X minus 6 equals 0. X plus 2 equals 0. And I solve it. What minus 6 equals 0? 6. What plus 2 equals 0? Negative 2. Now, if I check this in the original equation, 6 minus 5 is 1, okay? 49 minus 8 times 6. 8 times 6 is 48. 49 minus 48 is 1. The square root of 1 is 1. So 6 checks out. Negative 2. Negative 2 minus 5 is negative 7. Whoa. Negative 8 times negative 7 is 56. 49 plus 56 is a number, it's 105, and so I get negative 7 equals the square root of 105. That's not true. Negative 2 does not work. That's an extraneous solution. An extraneous solution is a solution that I solve for, but when I plug it back in, it does not work. Okay? That is actually 19. What is an extraneous solution, and how can you tell if there is one? An extraneous solution is a solution that you find, but it really doesn't work. How can you tell if there is one? You test it and see if it is the solution. Okay? Check. We've done that one. Now, let's look at this one. Solve each equation for the specified variable. Solve this for r. Big thing, there's r. So this is going to look like r equals when it's done. I'm actually going to put that in a box right here. I'll put my answer there. Okay, so I need to get r all by itself. R's under here under that root, but here's this 2 pi. I need to divide 2 pi first so that I can start getting that root. I'm stripping things away one layer at a time. Now, I've got t over 2 pi equals this square root of r cubed over gm. I've got to get rid of the square root. To do that, I'm going to bring each side to a power of 2. Remember, roots undo powers and vice versa. So let me rewrite for a second. I've got t over 2 pi squared equals r cubed over gm. Okay. Now, guys, study your homework. I'll promise you, if you study your homework, you'll have seen everything that I could put on here. Okay. R cubed gm. This is the next thing I'm going to strip away because I'm going to do this before I get to the exponent. This is being divided, so I'm going to multiply by gm on each side. That cancels. Now the only thing I have left is that cube. To get rid of a cube, I take a cubed root on each side. And so I end up with r equals the cubed root of gm times t over 2 pi quantity squared. And there it is. Okay, now let's do this. G equals gm sub 1 over r squared, solving it for r. Now, one of the big 4 things that I said is if you're solving for a variable in the denominator, multiply each side by that variable. So I'm going to multiply by r squared. And so I get r squared g equals uppercase G m sub 1. Okay, cool. I'm solving for r. Let's get rid of the g by dividing by g. Okay, now I look, the only thing I need to get rid of is that squared. So I'm going to take the square root of both sides, and I get as my final answer r equals a square root of gm sub 1 over g. And I told you in one of the hints, when you take the square root, don't forget the plus and minus. That's it. Okay, cool. Okay, find the inverse of each function. Okay, to find the inverse, I'm going to pretend this is a y for a second, and then I'm going to switch the x and the y. So that would give me x equals the cubed root of y plus 2 minus 3. Because remember, inverse equations switch the input and the output. They switch the x and the y. Now I'm going to solve for y. To do that, I'm going to add 3 to each side. Okay, so I get x plus 3 equals the cubed root of y plus 2. And then I will bring each side to a power of 3. That's gone. And I'm going to come up here to give myself a little more room. Sorry. And that gives me x plus 3 cubed equals y plus 2. To get rid of that plus 2, I'm going to subtract 2. Subtract 2, subtract 2. And I get x plus 3 cubed minus 2 equals y. And to finish it off, I'm going to put it back in inverse notation. I'll use F inverse for that. F inverse equals x plus 3 cubed minus 2. And there we go. Cool. Okay, this other one. Find the inverse of this. So I'm going to pretend that's a y. And then I'll switch the x and the y. So x equals 1/4 y plus 9. Okay, I'm going to solve for the y. Minus 9 on each side. And I get x minus 9 equals 1/4 y. And now I need to get rid of the 1/4. I could do that either by multiplying everything by 4 or just dividing by a fourth. I'll just divide by a fourth because that's what I feel like doing right now. And so I get y equals x minus 9 over 1/4. Put it back in function notation. F inverse of x equals x minus 9 over 1/4. And there it is. That's also the same as 4 times x minus 9, which I could distribute out as 4x minus 36. So both of those are good. Use the table to write the table of the inverse of the function. Okay, so the inverse of the function is going to look like f inverse of x. That's going to be my labels. And this is really easy to do. I've got 1, 2, 3, 4, 5 points. So I need to make 1, 2, 3, 4, 5 things. Negative 412 goes to 12, negative 4. Negative 310 goes to 10, negative 3. I'm just switching the x and the y. See it? 0, negative 3 goes negative 3, 0. 1, negative 6 goes negative 6, 1. 2, 0 goes 0, 2. That's it. Okay. Oh, use the graph to draw the inverse. Well, this graph goes through the point. It looks like negative 3, negative 1, negative 3, negative 1. The opposite of negative 3, negative 1 is negative 1, negative 3. So I'll go negative 1, negative 3, and it's going to start there because the function f started right there, so the inverse is going to start there. Let me think. I'm going to pick look through here. I'm going to pick points that goes through nice and pretty. Negative 2, 0. So negative 2, 0, flip that goes 0, negative 2, so right there. Okay, and oh, look, it goes to the point 1, 1. Wait, 1, 1, if I switch it, that's just 1, 1. So it's going to go right through there again. So this is going to go up there. See if I find another pretty point. Right there. Seems to go through this exactly. That's 1, 2, 3, 4, 5, 6, 6, 2. 6, 2 is 2. 1, 2, 1, 2, 3, 4, 5, 6 right there. And that goes forever that way. Now, you can verify that because if I graph the line y equals x, there is that reflection. So take the points that this function goes through, switch them, the x and the y's, and then just connect the dots. That's all you're doing. And now remember, not all functions are going to have an inverse, only those that will pass the horizontal line test. Remember, the horizontal line test says if I graph a function, and a horizontal line spelled L-I-N-E, hits it twice, that function has no inverse. I'm sorry, I'm writing this really fast. No inverse. I'll give you an example. If I give you y equals x squared, that looks like that. And I hit a horizontal line. Oh, see how it hits it once, twice? Because it hits it twice, that function has no inverse. Okay, I know that was quick. You can zoom in, zoom out to get a little better view on things. You can speed it up, slow it down, whatever. But that's how you work through any other problems. If you're not sure of whatever's going on and still why we're doing things, come and get some help. Okie doke. Bye-bye.